All right, first thing they asked me to do here was to graph between negative 2 pi and 2 pi and state the domain and range. First thing they asked me to graph was y is equal to the sine of x. So remember, you put 4 tick marks on either side. Highest it's going to go is 1, lowest it goes is -1. Sine goes through the origin, so remember that. Then it reaches the maximum, cuts the axis, reaches the minimum, cuts the axis. So it kind of looks like top hump, bottom hump. And then here and here and to the top and here. So they asked me to graph it in general between negative 2 pi and 2 pi. It's going to have a domain that's all real numbers, or negative infinity to infinity. And it has a range that goes from -1 to 1. All right, next they asked me to graph negative sine of x between negative 2 pi and 2 pi. So I still put my 4 tick marks. 4 tick marks here. You really only have to label 1 in each quadrant officially. When we graph reciprocal functions, if they're asking us about vertical asymptotes, maybe you want to label every one of them, but for these it's not a big deal. Remember, negative sine of x is a reflection of this about the x-axis, because when you make a function negative, it reflects about the x-axis. So when you reflect 0 about the x-axis, you still get 0, but if you reflect 1 across it, it's going to be -1. The 0 will be the same, but when you reflect this across, it's going to be up here, and then this. So when you make it negative, it just looks like bottom hump, top hump, like that. And then same way here, this is on the bottom, but now it's going to be on the top. The 0 is going to be the same. This was on the top, but now it's going to be in the bottom. Then here. So it looks like bottom hump, top hump. There we go. This still has a domain that goes from negative infinity to infinity. And it still has a range that goes from -1 to +1. All right, next we're going to graph cosine. Do 4 tick marks. Highest it goes is 1, lowest it goes is -1. Cosine starts at the top. It does not start at the origin. It starts at the top. The only thing left to do is cut the axis, reach the minimum, cut the axis, reach the maximum. So on the right side, it kind of looks like a tulip, I think. And then on the left side, kind of does the same thing. All right. And so its domain goes from negative infinity to infinity. You might say, but Puckett, you only graph from negative 2 pi to 2 pi. Yeah, I did. But in general, for the function, the domain is negative infinity to infinity. It keeps going on forever. Okay? And the range is the same as was for sine. It's -1 to 1. If you just look at this, and he starts in the middle, remember cosine is in the middle of the thing. Kind of looks like a ghost. Ooh. All right. Negative cosine. Negative cosine will just be cosine except for a reflection across the x-axis. There's 2 pi. There's -2 pi. There's 1. And there's -1. So remember, cosine started here, but now if it's a reflection across the x-axis because it's negative, then it'll start down here at the bottom. Let me make sure you can still see this because I just kind of moved that, but I think it's still okay. All right. And then it's going to cut the axis, reach the maximum, cut the axis, reach the minimum. So it kind of looks like upside down tulip, or now that looks like a ghost by itself. Across the axis, reach the maximum, cut the axis, reach the minimum. This kind of looks like two ghosts. Ooh. All right, never mind. Domain is negative infinity to infinity. These eyes and mouth are just optional. You do not have to draw this in. The range still goes from -1 to 1. All right, done with graphing. Now let's find the exact value. Let me make sure I'm in camera view. Good. Cosine of 405. Where is 405? If they give you a number bigger than 360, just subtract 360 from it. So this gives me 45 degrees, okay? So, because what happens is you go around 360 plus 45 more. So it's the same place as 45 degrees, which is square root of 2 over 2, square root of 2 over 2. Cosine is the x-coordinate, so the answer will just be square root of 2 over 2. Next question says, what's the sine of negative pi over 4? If they give you a negative angle, instead of going counterclockwise, you go clockwise, so you go downhill first. So negative pi over 4 would be right here, and the coordinate there is square root of 2 over 2, negative square root of 2 over 2. Sine is y, and so the answer will be negative square root of 2 over 2. Next question says cosine of negative 120. Remember, if you travel negative, you go down to negative 90. And if you go negative 30 more, that would be like right here. The coordinate right there is left 1/2 and down square root of 3 over 2. And so cosine is the x-coordinate, so it'll be negative 1/2. Cosine of negative 60, negative 60 goes like negative 30, then negative 60. So it's right here, which is right 1/2 and down square root of 3 over 2. And so cosine is the x-coordinate, so it's positive 1/2. Cosecant of negative pi over 3. Isn't negative 60 and negative pi over 3 the same place? Yeah, it is, because this is negative pi over 6, this is negative pi over 3 right here. Okay, same way positive pi over 3 is right there. So the coordinate right here is over 1/2 down square root of 3 over 2. So if I ask you what is the sine of negative pi over 3, you would tell me it's negative square root of 3 over 2. The reason I'm saying that is because cosecant is reciprocal of sine. So the reciprocal would mean that it's going to be negative 2 over square root of 3. Just flip this upside down. Now the deal is it's not, they're not going to leave it that way, because that's like bad math manners to leave a radical in the denominator. So they're going to rationalize it by multiplying the numerator and denominator by square root of 3, which gives you negative 2 root 3 over 3, and that's your answer. Next, they ask me what's the sine of negative 30 degrees. Negative 30 is right here. You go over square root of 3 over 2 and down 1/2. Sine is the y-coordinate, so it'll be negative 1/2. All right, so that's that.